So this is my book. You can go here. This is actually the relevant section, core commands. From here onwards, I will be into the core Hadoop, which means we'll be using Hadoop for data processing. Till now, it is only for requirements, and I only dealt with one of the requirements, that is Linux. The other requirement is Java, that I didn't open till now. So after this core commands, I will be opening the discussion on Java, not as it was explained in my material, but I'll be discussing with you very few examples. Okay, so these are core commands. Here there is a screenshot. This is not a screenshot, I guess. This is a table. So I'll be doing one small activity using Hadoop core commands guide. It's not core commands, actually FS. These are core commands. So we'll not be using all these all these commands. We'll be using only very few of the commands, just like check native, class path, and then FS. FS is perhaps the most important command among all core commands. And the rest of them are not useful for us because we are not working on full-fledged multi-node cluster. It is just whatever the cluster that I'm using is only a single node pseudo distribution. We call it a pseudo distribution, which means a fake cluster. So that is why it is not possible for us to work with all these commands. So very few commands, but FS is very, very important. This there is a separate shell guide, the HDFS shell guide, something like that. You go here, say file system shell guide. So there are approximately some 20 to 30 commands. So not all of them are useful. Very few of them are useful once again. But for data processing, we'll be using only very few commands. So just like append to file, whatever it appears to be related to file, those commands are useful for us to deal with HDFS. Suppose if I take append to file, okay, this command is useful to append information from one file to the other file, and from here onwards, okay, will be inside Hadoop. So what I mean inside Hadoop is like there is LFS and there is HDFS. So in the base system, you got local file system, and there is a Hadoop file system. So local file system, this is just a disk. So that is why everything is structured. You have a structured file system. This is LFS. So you got that data, this data, and all data chunks will be. So file system is memory. File system FS. There are different types of file systems. Okay, we have network file systems, desktop file system, NFS center, desktop file system, DFS center, distributed file system, DFS. Like a LFS local file system. These are all just a kind of fictitious, titles for memory. So file system is meant for memory. So here what happens, you will be having the chunks of memory here. So this is one kind of, these are all actually the files. So file system deals with the files. So these files will contain the data. So this file system will have some sort of numerical data, and this file system will have some textual data, and this file system may have some sounds, or this file system may have some videos. Okay, here is sounds, and these are videos, and here you have some text. So these are all, usually we have the file means we refer like this. Okay, in computer this is file 1. In file 1 you have some numbers. In file 2, you have some text. In file 3 you got some kind of you can also have some cryptographic data like passwords and all. In systems we got log files, you got PASW files. There are system level files. So file system essentially is meant for storing the files inside which we have data. Now we have local file system. Every computer is going to have the local file system, and apart from it there is HDFS. This is a cloud in HDFS center. So now after installing in Hadoop cluster, if we install Hadoop, then apart from the local file system, we'll be having HDFS. So this HDFS is Hadoop file system, Hadoop distributed file system. This file system is nothing but the mapping of different computers. So here, this is one computer. You may have another computer here. You may have another computer here. You may have other computer. This is a LAN. So this HDFS is actually the file system, which is a mapper. Which is actually a kind of cloud formed from all the file systems of the computers. So here you have LFS, here you have LFS, here you have LFS, here you have LFS. All these LFS. So HDFS is nothing but LFS1 plus LFS2 plus LFS3 plus. Why? Because all these, so Hadoop is not going to identify the data. We'll be administering the data. Like, we take the data from one computer and then see that it will pass through the HDFS, and then it is all up to us. Like, Hadoop is not going to read the data automatically from the local file systems. We only push data as per our requirements. Suppose if I have some data here which need to be handled by Hadoop and which need to be identified across the cloud, then I have to take that data file into the HDFS. Now, I'm going to do a small activity. So that activity is just, I'll be creating a file in my LFS, local file system, somewhere in some directory. And that I'll take that file into the HDFS. Hello, are you all following me? Or am I speaking to myself?
We are following this.
Okay, thank you. So for that, I need to use a couple of commands. So some of the commands is copy from local. So what I'm going to do is, I'll be just doing like this. So step number one, I create a file, and then step number two, copy file, okay, file from LFS to HDFS, and then again, I come back to the local file system and then put some data or put some additional data, and then I try to append the file in the HDFS with the help from the local FS. Append data from LFS file to HDFS file. So first I'm going to create a file and I put some data into it. Then I take that file to HDFS from, see here, whenever I talk about the LFS and HDFS, you refer to this figure. I'm taking from the local computer to the Hadoop cloud. I mean that network file system or distributed file system. I'm going to take that data from LFS local file system to Hadoop distributed file system, which is actually the mapper. It's a mapping. It's a cloud which has all the data inside the LFS. Then put some additional data in the local file system and then append it to. So here, to create the file, I will be using the plain Linux commands. Okay, gedit and all, and I copy paste all the data and something like that. And then to copy the files, then I use some HDFS, FS commands. So that is actually the advantage of using Hadoop inside Linux. Okay, and then put some additional data. Again, I use some base Linux commands, and then I use HDFS commands for appending data. So here the command is going to be copy from local. The command. So Hadoop command which I'm going to use here is copy from local, and here append to file. I think if I am correct, append to file. That's correct. Append to file. So every time I use copy from local, there will be source. Now let's go and see the format for the copy from local. So I think you don't have the syntax given in Apache, but I'll tell you. This is also, you can also use put command, copy from local or put. And to download the data, that we'll do it later. That is exercise number 2. This is exercise number 1. This is one of the lab exercise. This is exercise 1. This is lab exercise. You have to do this experiment in the lab. Okay, so how am I going to do that? So all of you are going to watch me, and you have to do it in the same fashion as I'm doing in this computer. I think this is the master. I remember, I don't know. Hadoop is the master and the slave is Hadoop slave, I guess. So I don't need all the computers, but I'm going to start both of the, I have a 2-node cluster here. In my, office computer, I got in my personal, I have the 2-node cluster. So here Hadoop, I don't need both of the nodes for this example. I can just do it Hadoop. And here I also start the slave. because it will throw error if you have the two node cluster. It doesn't happen. Like you don't necessarily need to start the entire LAN, but it's better. So here I have Hadoop version 3.3.2. In slave, let me see. Let me show you Hadoop version. I have the same version, and here host name. It should be master is, and the host name, because I have so many. Yeah, this is slave. So here I'm going to start. See, I'll show you both in both machines JPS, Java Process Service. So there is no daemon at all. Java daemons are not running right now. And come here, JPS. Now I'm going to start the cluster from master. Please be cautious. Look at me very carefully. To start the cluster, I need to use start all. Actually, I should start daemon by daemon, like start DFS, start map on, start like that. But there is one composite command called start dash all dot sh. If I now the daemons will start, and only to show you that it is a two node cluster. Keep watching what I do. So once the daemon starts, the slave must be able to recognize the master. That is the only evidence why the SSH is exiting with. Oh, okay. I'm sorry. JPS. I'm sorry. I think I should go for HD user or Hadoop user. What is the users? Hey, users. This is Hadoop, right? I think CD root login LS. Yeah, Hadoop user. CD SU Hadoop user. I'm sorry. I have to log into the. I created Hadoop user for two node cluster, but single node you don't need this. Okay. I think Hadoop, I guess. Yeah, Hadoop. Now CD. Now start all .sh. Now this time it will start. I have to log into the Hadoop user to start the cluster. Otherwise, it will not start. Now it is starting. Earlier there was an error. Name node started, data node started, and then secondary name node started. Resource manager is starting, node managers are starting. These are all daemons. Daemon means processor, process. Java Hadoop processes. Hadoop daemons are starting, which means Hadoop processes are starting. Daemon and process, both of them are different, but they're identical. Okay, so I cannot explain you the difference, but for time being, a daemon means a process. Okay, you don't need to confuse with. Now JPS. You see, name node is there, resource manager is there, secondary name node is there. Now, I didn't do anything in slave, right? If I verify with the JPS, it's not recognized. I think there is something wrong. It will take time or what? Okay, fine. So data nodes should, resource manager should start, node manager should start here in slave. Something went wrong. Okay, fine. So now Hadoop is started, and should this okay, I'm sorry, I'm doing the same mistake. Hadoop user. Okay, CD back ls Hadoop user. SU Hadoop user. Hadoop. Same mistake I'm doing. There I did the same. JPS. You say node manager. See here, I didn't do anything here in slave, but automatically node manager starts. And data node also. This is data node. Please be cautious. This is name node. Master is the name node, and here this is data node. So here after only one master, but there'll be n number of slaves or data nodes. Every slave is a data node, which means it is a node where there is data. And this is a name node. Name node means a master, which maintains the journal of the different data nodes. Suppose if there is a LAN with one master and 4 slaves, there are 4 data nodes and 1 name node. So that is actually the calculation. That is how cluster will be calculated. Or so ipudu I can start using the Hadoop commands. Hadoop fs, because I'm going to. So now let's go back to this demonstration. What I'm going to do, I'm going to create a file, and I copy that to take that file from local file system to HDFS, and then I append the data. Now, where is the file? So, I am in the, I have already created a folder called data. If you don't have that, you have to create sudo mkdir data, something like that. I already did that. Okay, I have a file called gender master. So it is gender based data, and it is there in the master. Okay, cat gender master. So this is male, 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 female. So there are 3 male and 1 female, right? Let's go back to slave and see what I think I should be having the same data file here. ls cd data ls. I have only gender. So here, let's see what I have. Cat gender. Yeah, I have here. I have male, 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 female. Okay, in master file system, I got a file in which there are responses which are different from the slave. Please be cautious. Now we are going to analyze both of the data files using Hadoop. Okay. Now in this computer, let me verify what are the different directories available in the HDFS. I am in this data. This is LFS. I am in LFS, local file system. You see here, this is the path file. So this is the path. So what is the path? PWD. I am inside Hadoop, home Hadoop user data. That is actually the present working directory. And this is LFS. Now, where is HDFS? Hadoop. To know HDFS, Hadoop FS. Okay. -ls /. So which means show me the root file system in HDFS, Hadoop distributed file system. Now Hadoop daemon is working. So I have a folder called data. Same folder. The folder which I have in local LFS, same I created. Now I want to see what is there inside data. Simple. Hadoop fs-ls list. Now, if I want to see in any directory the ingredients of a directory, ls. Same thing we can also do, but a bit different. Hadoop fs means file system in Hadoop. And what is the name of the file system? HDFS -ls and data. Now I already have that. There is a file called gender. There is a file called gender. I deleted. So Hadoop HDFS lo ఉన్న directory lo data ni delete chestam. Okay. How? Hadoop fs rm. Okay. I think let me see -r works or not. I'm just experimenting this. Let me deleted data. Now same, go back, and I want to see ls root file system. There is nothing. So I deleted that folder data in Hadoop HDFS distributed file system. I deleted. Now I'm going to copy the data. That is the step number 1. So where is it? This one. Copy data from LFS to. So I already have data files in my LFS local file system. Now I'm taking those files to HDFS. How? Hadoop. I'm in the same folder. Please be cautious. I'm in LFS in the same directory. So that Hadoop fs copy from local. Copy from local. What files? I want to send gender master.txt to where? Data. So this is source. ఇదంతా మీకు గుర్తులేదు అనుకోండి. Okay, I'll do it once again. So this is Hadoop fs copy from local. What file? Gender. I am in the same directory. Please be cautious. This file is there in this directory. I'm in the same directory. Gender. Take this file. This is the source path, and then put it in the directory called data. It may happen. It may not. Why? Because the directory is not there. I didn't create that directory. Okay. Let's see. I think it will show you the message. I think it created. Okay. Hadoop fs -ls root. It has created a directory. That's okay, fine. And now what is there inside data? There is file. Oh, there is nothing there. I think that has, it's not a directory. Cat, I think okay. I can use this one called cat dash cat. Cat is the same Linux based command. If I use this, let's see. Yeah, that was actually it's wrong. I cannot do that. Okay, Hadoop fs rm or because I want to copy the file as it is. I actually change. I have to create it. So that is not a correct way. I have to create the directory first and then take the file to the directory rmr data. I'm deleting that that data file with the name data. Now Hadoop, let me create the directory fs mkdir, same mkdir Linux command. Now data Hadoop fs ls. Show me what is there in HDFS. Yeah, there is a folder called. It is a folder data. Now Hadoop fs copy from local gender.txt where to this folder. Now the data is not now one more time ls. I want to see what is there in the data. Now there is a file, right? Gender master.txt. Now I can use cat. If I want to use cat, Hadoop fs cat data and then gender. Here tab will not work. Please go gender master.txt. What is there inside that file? Yeah, there is some data. So now I finished. So there was a file in my local file system. I've taken that file to the HDFS. Now there is already data. I don't need to put the data into it. Now what I do is that you see the base file has got cat, that is a local LFS cat command, cat gender master. I open this file and put one more female there. Okay, sudo gedit. Okay, gender master.txt Hadoop. Now I go to the bottom of the female. Now there are two females. Please be cautious. Ipudu, I don't want to copy this there, but I want to append that. To the ipudu mottam append avutundi. The whole. Danik, I think there are two ways to append the data. I forgot it. Actually, I too have to read it. Append to file. There are two ways to append to file. Append to file. Yeah. Hadoop fs append to file, local file, and destination file. Okay. Append single source or multiple sources from local file system to the destination file system. Also reads input from stdin and appends to destination file system. Reading alaga std return 0 and 6s and that is okay, fine. Cat is fine. Append file, local file. There are two ways to append. One is to append only the extra fields, records, or to append the whole data. Append to file, local file to name node. This is the name node. Appending to the name node. HDFS name node. Okay. I think this one, I guess, reads from the input standard. Okay, fine. So we don't need to be that serious to append the file. So now I use Hadoop. Okay, Hadoop fs dash append to file where I want to append gender text to data gender master.txt. Appending, I guess. I don't know once. Yeah, now I want to cat it. Cat data gender master.txt. I don't know how many of you are following me. See how many. Now the file in the HDFS have been appended by the whole. I will tell you how to discard the existing data and overwrite. It is overwrite chedu. Whatever the content that you have in the in the base file, that content will be appended to the HDFS file. So this is one. So now I've shown you how to take the file from the local file system to the HDFS and also append the data from the local file. Now let's go to the slave. Okay, I did everything from master, right? So till now I have been doing everything from the master. Now here I want to check that from the, can I access that HDFS from, see, if the HDFS is a cloud, Hadoop cloud, or if it is like a distributed file system, then I should be able to access that from any computer in the LAN. So now Hadoop FS ls. So now I'm in slave, I'm not in master. So I should be able to see that file. Yes, there is data. Now let me use what is there in data. I'm doing everything from the slave, which means data node. It's not slave actually. In Hadoop jargon, it is a data node. So there is gender master. Now Hadoop fs cat data gender master .txt. Yes. So now ఇప్పుడు ఏం చేయాలంటే మనం ఇక్కడ లోకల్ ఫైల్ సిస్టమ్ లో ఒక ఫైల్ ఉంది, ఏంటది? ls gender, right? Now cat gender, okay, gender.txt. This is, see, this data is different from this data. Actually I would have done this one there, but anyway, fine. Now I'm going to append this data to the HDFS. So HDFS is actually the distributed file system which is atop of above these two computers. So from any computer you can access the HDFS. This is actually the advantage of Hadoop. We are getting everything, the whole infrastructure free. That is actually the popularity of HDFS. So you will, if you want to do all these activities on your own way, it will take roughly a day. One day it takes to write your own programs to, copy from one place to the other place and all. Hadoop offers everything. Now, how do I append this data to the HDFS? Can somebody tell me what is the command?
Append to files.
Huh? Sorry, Srikant.
Sir, append to file.
Append to file. Hadoop fs append to file. Where is it? Gender. In slave it is gender. Slave gender data gender master.txt. Yes. Now Hadoop, I want to see the contents of that file. What is the command? Hadoop fs dash cat. Very good. Very, very good. So I thought you so gender master.txt. Here something happened. Data. It's not Hadoop. Data gender master.txt. Yes. So we got all the, so we appended the HDFS file with both data from both the name node as well as data node. So now all the data is there inside. This is how this is how the LAN Hadoop works across the LAN. Now I've shown you how two node Hadoop cluster will work. So now you can process data from the anywhere, like you can use name node or you can use slave node. It just works. That's all. Now what happens? So we have done our exercise, right? So I've taken the file to the local file system to the HDFS, and also I appended the data. Now this is one of the exercises which you have to work. Okay, from here onwards, now we got the data. So we have taken care of the memory. So memory is the Hadoop distributed file system, and we got the data already. Now what? What next? We need to process the data. Okay, processing comes next. I still have 10 more minutes, and I'm just going to show you one small algorithm in Hadoop that is called word count. Okay, there is a word count. It's not a Hadoop algorithm actually. It is word count is there in every programming language while teaching textual analytics, text mining, we use an algorithm called word count. Java is very popular for it. And, here, now I'm going to talk about the MapReduce. Okay. I'm going to use a word count MapReduce script. Okay. Hadoop script, MapReduce script to analyze this data. So now what is this data? This data is nothing but, some gender-based data. So like, in our survey, we'll be having, this is actually, there are, I don't know how many of, I can even, I don't kind of count, I guess, Hadoop, FS, count, ante count daniko, I don't know, I'm just using it, gender, just vadestunanu, but gender master.txt, the word count veru. There are, I think, I don't know what is that. I think this is only one file, I guess. Shows one file, 84 bytes, right? I don't know. Hadoop FS LS data. Oh, okay. Yeah, 84 bytes or kilobytes, I don't know. So this is actually the memory. There is only one file, but it will not count in, but in Linux, we got, so number of lines we have to write the program, Java program. So I don't think we have any command in HDFS command which counts the, we don't have we have to write our own command. So that is there where actually the MapReduce comes into the picture. Now what is going to happen is I have data, and this is actually a variable, a gender variable. In survey data analytics, we collect gender-based data, male, female. This is some kind of, now what I want to create a frequency table for this data. I want to create a frequency table. So this word count, what it does is that it's just going to count the number of instances that which belongs to male as well as female. Across open this and word count MapReduce program. Now, this one Java point. No. I want to go for Apache Hadoop, and here this is the program. So this is just Hadoop MapReduce program to make the frequency table for gender-based data. Okay, this is just going to, in the internet there are discussions, so I'm not going to talk about, if I start to open this discussion, you'll be nowhere. So right now, this is just a script. This script already undi. When we install Hadoop, we automatically get these, algorithms. Where are they? That is the question. Okay, I'm in the master. In master, what happens? I'll take you to Hadoop working directory, home directory. Hadoop home. Hey, what happened? Why it is not coming? Hadoop home. I don't know. Okay. Oh, it's not going. Why it is not going? I don't know. CD. Hadoop. Okay. User local Hadoop. And then in that we got SBin, and let's go there. Yeah, here you should be, it's not SBin actually, share, I guess. Share, CD share. Yeah, share. Yeah, CD Hadoop, LS. Hadoop installation, home directory. Say Hadoop, user local Hadoop is my home directory, Hadoop home directory. In that there is a directory called share, and then there is Hadoop. In Hadoop, there is a folder called MapReduce. Even you got examples and not client to come, even in MapReduce examples. In MapReduce folder, you got MapReduce. MapReduce, you see here, there is an example file, jar file. This is the file where you have all, if I use Hadoop jar, see, I'm changing the command. Ippadi varaku Hadoop FS vadanu, ippudu jar vadutunnu. Hadoop jar to see the ingredients inside the jar. Hadoop MapReduce examples. If I press enter here, what happens is you'll get all the list of algorithms. This is a Hadoop jar, Hadoop MapReduce examples 3.2. Something like that. You see aggregate word count, aggregate word histogram, and DBP and DB count. These are all some pi value, estimation of the pi estimation. And there are a lot of, here you have one, the class called word count. This is a class. It's a jar file. Jar file means it's a Java file, Java compressed. Like you have var, tar, like that. Jar is actually the compressed collection of classes, Java classes compressed into a jar file. Jar file is a compressed format. Jar is a compression format used for the Java programming, Java programmers. So this is a jar file inside which you got so many, classes. So now this is actually the class which I'm searching for, word count. So word count is a class and algorithm which process the data. Yella vadale. Okay, now look at me. Hadoop jar. Okay, I have to go to this. I am in the same directory, so I can straight away use this. The examples for Hadoop. I think MapReduce Examples Jar. You see the name of the class is word counts, all small letters. Word count, and then my input file. Where is the input file? The input file is inside data, gender, master.txt, and where destination is data out one. So I'm just telling, take this directory. So process this data. This is the source. I have my data in this file at this path. Process this data and put those results into this output folder. So this is the source. This is the destination. Now the command is Hadoop jar, not fs. Please be cautious. And where is the class file? In this jar. What is the name of the class? Word count. So something like that. Now I'm going to hit the button enter. You're going to see the whole beauty of parallel processing. Okay, enter. Now parallel processing starts. I think something went wrong. No. Yeah, MapReduce. This is actually the whole 100. This is very fast. Actually, it will take a lot of time. I don't know. Completed successfully. This is very, very important. Job completed successfully. We'll discuss each one of it later in my next class. There's a lot of information Hadoop throws into and this information is very, very essential for data analyst. And this is very important for us. So MapReduce, both of them has been processed parallelly. This is parallel processing. అంటే ఫాస్ట్గా అయిపోయింది కాబట్టి మీరు చూడలేదు. యాక్చువల్గా ఏమవుతుందంటే ఈ రెండు కూడా చేంజ్ అవుతూ ఉంటాయి అనమాట. ప్రాసెస్ జరిగేటప్పుడు మ్యాప్ వెన్ ఇట్ ఇస్ 20% and reduce will be 10%, and map goes to 50% and reduce something like that. Now job successfully. Now where are the results? Okay, results are there. Now I'll go to the slide. So because that is everything is clogged with a lot of statements. And now Hadoop fs cat data out one. This is the folder where I want to see, not cat actually, ls. I want to see what are there in that folder. Beautiful. So there is a success. There is a file with success, and there is a file with part dash or 5 zeros. This is important. Okay. Now how am I going to? I can download it down to the LFS, or I can see there itself. Hadoop fs cat, okay, data out one, and what is the name of the file? Part dash r means reduce. I mean, this file has come from the reduce step. That is what it shows. 1 2 3 4 5. Now show me what is there inside that file. There are 7 responses which belongs to female. There are 7 responses which belongs to male. This is what is called data processing. Okay. So now the